Hello students, welcome to my channel Learn, Grow and Rise. Today we are going to discuss one important law of chemical combination, that is law of conservation of mass or LCM. In this topic we will discuss introduction, statement, experiment, example, significances, limitations and few questions to make your concept more clear in exam decode, and finally summary of the concept. So, without wasting our time, let's discuss. Let us find out the terms present in the law of conservation of mass. One is conservation. The meaning of the conservation is nothing changes, everything remains same. And another is your mass. The meaning of the mass is amount of substance present in the matter. To make milkshake, milk and chocolate powder is needed. Mass of glass of milk here is 450 gram and mass of the chocolate added is 50 gram. Mass of the glass of milkshake after preparing it is 500 gram. From this data, it is clear that when 450 gram of the milk that reacts with your 50 gram of your chocolate, its value is 500 gram. And when we measure the glass of the milkshake, we also got the value is 500 gram. So it is clear that there is a conservation of the mass. No change in the mass takes place after the preparation of the milkshake also. So it means that there is a no loss of the mass or no gain of the mass. So nothing changes here. Everything remains same. Hence, it is the meaning of the conservation of the mass. The law of mass of conservation, the law of conservation of mass discovered by Anthony Lavoisier, and Anthony Lavoisier is known as father of modern chemistry. According to him, mass is neither created nor destroyed in chemical reaction or physical changes. Means when a chemical reaction or any physical change takes place, the mass present before the reaction is equal to mass present after the reaction. The total mass of the reactant is always equal to the total mass of the products. To prove this statement, Lavoisier conducted so many experiments. One of the experiments is he took some mercuric oxide in a jar, sealed the jar and recorded the total mass of the setup, and after that heated it. He found in all the cases that mass of the reactant is equal to the mass of the product. When he heated the mercuric oxide, he got mercury and oxygen. He has taken the weight of the mercuric oxide is 100 gram. When he heated it, he got 92.61 gram of the mercury and 7.39 gram of the oxygen, and he concluded that the mass present before the reaction is equal to the mass present after the reaction. And also he concluded that in a chemical reaction, atoms are neither created nor destroyed, only they rearrange themselves to form a new product. So let us take one example to make our understanding more clear. Photosynthesis is a natural process in which plant absorb the carbon dioxide from the atmosphere and water molecule from the soil to prepare its food in the form of the glucose and release the oxygen gas to the atmosphere. So, for this process, plant required 6 molecules of the carbon dioxide and 6 molecules of the water, and prepare 1 molecule of the glucose and 6 molecules of the oxygen. Now let us see that whether in this natural process the mass is conserved or not. The process follows the laws of conservation of mass or not. Now let us see. The mass of the carbon dioxide used here is equal to 6 into 44 is equal to 264 gram, and the water used here is 6 into 18 and the value is your 108 gram. Now, the total mass of the reactant is equal to 264 plus 108. You will get the value is your 372 gram. Now, let us find out what is the mass of the product here. The mass of the glucose here is 180 gram, and mass of the oxygen here is equal to 6 into 32 is equal to 192 gram. So, the total mass is 180 plus 192. So, the value you will get is equal to 372 grams. So, it proves that the total mass of the reactant is equal to total mass of the product. So, in this process also, what we concluded that total mass of the product is equal to, so total mass of the reactant is equal to total mass of the product. Hence, it follows the law of conservation of mass. Conservation of mass. Now, let us know the significance of this law of conservation of the mass. The significance is that it is used to calculate the mass of the unknown reactant or the product. It is also help in the calculation based on balanced chemical equation. For example, when the hydrogen reacts with oxygen, it produces water. Suppose 8 gram hydrogen react with X gram oxygen, the unknown mass is X. Then it produces your 72 gram of water. Now we can calculate what is the mass of the oxygen required in this case so that we can get 72 gram of the water. We know that total mass of the reactant is always equal to total mass of the product because the mass cannot be created or cannot be destroyed. So what is the value of the oxygen used here? So X is equal to 72 minus 8 is equal to 64 gram. So this is the most important significance of the law of conservation of mass. Now let us discuss what are the limitations of this law. The first limitation is that this law is not applicable for the reaction take place in open system because in an open system both mass and the energy both are exchanging with the surroundings. When the reaction takes place in an open system, maybe some product or reactant escape out to the surrounding or maybe some new substance that may be added from the surrounding to the system. So, in this system, we cannot use the law of conservation of the mass. Another limitation is that this law does not applicable for the nuclear reaction because in the nuclear reaction, some mass converted to energy. Hence, this law is not applicable. Now, let us practice few questions in exam decode session so that you can make your concept clear. But please pause the video and practice the question and after that see the solution given by me. If all the questions are correct, so you have understood completely the lesson in a better way. So give a star mark to you. If 2 questions are correct, then please watch it again. Now let us start the solution. The first question is that in a chemical reaction, 200 grams of reactant A are combined with 100 grams of reactant B. Both A and B react to completion. How much will be the product weight? So, what is the solution? According to the question, A react with the B to produce product. We need to find out the weight of the product, let it be X. So 100 gram A, mass of the A is your 200 gram and mass of the B is your 100 gram. Okay, so what is the value of the X? X value is equal to 100 plus 200 is equal to, you will get the value is equal to 300 gram. You will get the value is equal to 300 gram because total mass of the reactant is equal to total mass of the product. So answer is your 300 gram. Now let us solve the question number 2. In a reaction, 50 gram of reactant AB breaks down into 10 gram of the product A and an unknown amount of product B. Using the law of conservation of mass, how much does product B weigh? So in the reaction AB, it breaks to produce A plus B. So what is the mass of the reactant AB? That is 50 gram. In this 50 gram, mass is your 10 gram and B, let it be X. So the value of the X is equal to 50 minus 10 because 10 plus X is equal to mass should be 50 because total mass of the reactant is equal to total mass of the product. So the value of X is equal to 40 gram. Now the third question is that how much oxygen will add with 36 gram carbon to give 132 gram of carbon dioxide, assuming complete combustion of carbon. So carbon, when it reacts with the oxygen, it produces carbon dioxide. So amount of the carbon used here is 36 gram and let the oxygen used is X, and we are getting 132 gram of the carbon dioxide. So the value of the X is equal to 132 minus 36. You'll get the value is your 96 gram. Hope you enjoyed my video and like it. Please let us have a look on summary. The summary is that it states that the mass is neither created nor destroyed in a chemical reaction or the physical reaction. Anthony Lavoisier discovered the law of conservation of mass. Total amount of reactant is equal to the total amount of the product. Atoms cannot created nor destroyed, it only rearranged during a reaction. The significance of this law is it is used in calculation of many chemical reactions to find unknown mass of reactant and products. It does not applicable for the open system and the nuclear reaction. So hope you understand the concept very clearly. Please like, share and subscribe my channel, and please do not forget to hit the bell icon. Thank you.